Autonomous agents can reason, call tools, retrieve data, and act quickly. But if you cannot see those steps, you cannot secure them. In this module, we'll make agent behavior visible, measurable, and ready for investigation. Before we move forward, notice the progression. You have identified agent risks, constrained tools, defended against prompt injection, and designed human approval gates. Now we ask the operational question: did those defenses actually work? Module 5 focuses on the traces, events, metrics, and signals that make agent behavior visible and reviewable. For AI agents, observability means being able to replay the whole run, not just inspect the final answer. A useful record connects the user prompt, model responses, plans, retrieved context, tool calls, policy checks, approvals, outputs, metrics, and security events. That matters because autonomous workflows can fail in subtle ways. The answer may look fine, while a tool used the wrong data, skipped a guardrail, or required approval. With full execution visibility, teams can debug faster, detect abuse, prove compliance, and investigate incidents with confidence. Strong observability answers 4 investigation questions. First, what happened? The original request, each step, tool call, response, and final output. Second, why did it happen? The plan, reasoning summary, policy choice, and context the agent used. Third, was it allowed? Permissions, approvals, access checks, and anything blocked. Fourth, was it safe? Prompt injection signals, unusual tool use, data exposure, or abnormal behavior. If your logs cannot answer these questions quickly, they are just activity records, not operational observability. An execution trace is the timeline of an agent run. It begins with the user request, then records the plan, retrieved context, tool calls, tool responses, policy checks, and final answer. Its value is not just in logging errors. It preserves the chain of decisions and interactions, so teams can reconstruct what happened later. When a tool returns bad data, a policy blocks an action, or an output looks suspicious, the trace provides evidence. Use a unique run ID plus correlation IDs across services, so one investigation can follow the whole path. Think of an execution trace as the agent's black box recorder. It captures the request, session context, role, and risk level, so you know who initiated what. It should also record the plan, key intermediate steps, reasoning summaries, and decision points, so actions are explainable. For retrieval, keep the source documents, search queries, and relevant scores that shape the answer. For tools, log the call, arguments, permission checks, response, and final output. The goal is reconstructability with restraint. Enough evidence for debugging, audit, and incident response, but not unnecessary secrets or personal data. Tool telemetry needs to answer 3 questions: what was called, whether it was allowed, and what happened next. For every call, record the tool name, version, arguments, caller identity, timestamp, and result. Capture the guardrails around it too: permission checks, schema validation, rate limits, and sandbox status. Then add risk signals for actions like file access, network requests, database queries, or transactions. The key is balance. Keep enough evidence to investigate misuse, but redact secrets, tokens, and sensitive payloads using hashes where full values are not needed. The goal is not to record every thought the model could have produced. It is to preserve enough context for oversight, capture a concise rationale, the plan the system chose, important alternatives it rejected, and any policy or risk factors that shape the decision. At the same time, keep hidden instructions, secrets, proprietary reasoning, and private user data out of routine logs. Use redaction, role-based access, and short retention windows. Good observability answers: why was this action taken? Without turning the log into a new source of exposure. A useful observability program starts by deciding what counts as an event. Each meaningful agent moment, such as a run starting, retrieval happening, a tool call, a policy block, or an approval request, should become a structured record. Consistency is what makes those records valuable. Use the same identifiers every time: user, session, run, trace, tool, and tenant. Add timing, workflow, environment, severity, outcome, and risk labels. This turns logs from narrative text into data teams can search, correlate, and alert on. Engineering can debug behavior, while security can investigate exposure, policy violations, and risky patterns across the system. Security signals are the bridge between raw telemetry and actionable detection. Traces, tool logs, policy decisions, retrieval activity, and network behavior become useful when they reveal patterns. Prompt injection, tool abuse, access anomalies, data exposure, policy friction, or unsafe autonomous actions. Prioritization matters. A repeated refusal or access denial may be benign, but combined with unusual tool use and outbound traffic, it deserves attention. Rank signals by severity, confidence, user context, and likely impact. Not every signal is an incident, but every good signal should help an investigator ask better questions. Monitoring works best when you look for patterns, not isolated events. A single refusal may be normal. Repeated refusals can mean someone is trying to bypass policy. One denied request may be harmless. Many denials can suggest probing for privileges. Tool use is another strong signal, especially when an agent starts chaining rare or high-risk tools outside its normal workflow. Watch data access too. Sudden spikes in searches, downloads, or database queries may indicate extraction attempts. The goal is not to panic at every alert. It is to combine signals, then investigate quickly. Prompt injection rarely appears as one clean event. It usually shows up as a chain of weak signals. A user uploads a document. Retrieval pulls in hidden instructions like ignore previous rules. The agent then asks for data beyond the user's role or calls a tool that does not fit the task. Next, you may see encoded payloads, unusual domains, or file transfers. Observability connects these signals across prompts, retrieval, tools, and network activity. That context lets policy checks block the action early, before suspicious behavior becomes data exfiltration. Operational metrics turn agent reliability from a feeling into something measurable. Start with system health. Latency, errors, timeouts, and tool failures tell you whether the workflow is stable. Then look at efficiency. Tool call volume, retries, fallbacks, and retrieval usage show where cost or complexity is growing. Control metrics are just as important. Approval rates, policy blocks, refusals, and escalations reveal whether safeguards are working without creating too much friction. The key is segmentation. Break every metric down by workflow, model, tool, role, environment, and risk level so teams can pinpoint failures instead of averaging them away. All of these signals need a pipeline. Capture meaningful activity from the agent runtime. Logs, traces, events, metrics, and security activity. Instrument orchestration, retrieval, tools, approvals, and outputs in a consistent way, so each event can be normalized into a shared schema. Once signals use common fields, they can be correlated across sessions, users, tools, and incidents. From there, telemetry can feed dashboards, SIM workflows, data lakes, and response systems. Visibility also needs governance. Minimize sensitive data, enforce access controls, define retention, and keep compliance built into the pipeline. Agent observability is the bridge from secure design to safe, reliable operation. Execution traces show what happened. Security signals reveal suspicious behavior. Operational metrics show whether controls are working. With that evidence, teams can build trustworthy audit trails, alert on misuse, investigate incidents, and continuously strengthen the agent's defenses. Next, we'll turn this visibility into audit readiness and response.